Hi everybody, this is section 7.1, exponential functions and their graphs. This is the first section of chapter 7, and it's just one of two sections that we will be doing for this semester. And it's from our Hawkes Learning College Algebra textbook, edition 3.
All right, so an exponential function is a function where you have a fixed real number, positive real number, which, in our cases, our a here represents a. It can't be 1, because 1 to any power is always 1, so that won't work. But any number bigger than 1, positive real number, so, it could be 1.2, 1.1, 5, 6, 7, whatever, a number bigger than 1. And then it's going to be a to the x power. So now your variable is your exponent. And that's what an exponential function is, or what the equation looks like. Okay, so now we're going to look at the behavior of exponential functions. If you graph an exponential function, you probably, if you're watching the news these days, you're going to see tons of them because viruses tend to grow exponentially. And that is what currently, we're off of school for the coronavirus. That's what it is doing. It is growing exponentially. So the shape of an exponential graph is, just draw a graph there. And again, don't judge. You know my drawing. It's horrible. But the shape of an exponential graph is, it is going to start off and slowly grow. So it'll usually typically ride right along that x-axis, and then it's going to go up sharply. So, it grows slowly in the beginning, but then it starts to grow very quickly or very steeply, as we've kind of seen with our numbers here with the coronavirus. So the behavior of exponential functions. If you have a as a positive real number, so it's bigger than 1, you would have a decreasing function if a is between 0 and 1. So if you had a fraction, so, and which I said, a has to be bigger than 1, but it could be a fraction. It could be 1/2. It just can't be 1. So if a is like 1/2, 1/3, 1/5, 2/5, 2/3, then you're going to have a decreasing function. So that means, like, if I were to graph it and I made it 1/2, it would, instead of the way that I drew it going up, it is actually going to, if I can sketch it on here, it's going to start off real steep and then slow down. But it would be an increasing function, which is what I drew up here, if a is greater than 1. So if it's 1.1, 2, 5, 7, 8, anything greater than 1. In either case, the point 0, 1 lies on the graph, and the domain is the set of real numbers, and the range is the set of positive real numbers. Because if you notice with both of these graphs, and again, my drawings are bad, but the line will never, it's going to ride right along that x-axis, but it will never cross over the x-axis. So you'll never have any negative y values in there. And the same thing here, it's never going to cross over to the 0 or the negative values with that y-axis. So he's going to ride right along that x-axis. And I really want you to think, like, if we had 5 to the negative 2/7 power, when I go to evaluate that, if I have a negative exponent, or even 5 to the negative 2nd power, excuse me, if I have a negative exponent, I do, when I'm solving it, I take the reciprocal. So it's really 1 over 5 to the 2nd, or 1/25. And those fractions will keep, the denominators will keep getting bigger and bigger and bigger. So it'll get very close to that x-axis, but it never crosses over that x-axis. Okay, so here they want us to sketch the graphs of the following functions. You can graph them on your calculator. Really what we're going to talk about is, I want to talk about, again, the transformation of the graph, looking at the signs to it. What did they do? What happened to the graph? So here we have f of x equals 2 to the negative x power. So it's like 2 to the x power, but instead of x, now we have that negative x there. We got that negative x. Okay. So remember, when you have a negative and it's with that x value, it's going to mean a reflection. Now, is it going to reflect over the x or the y-axis? Hopefully, if you recall from the previous sections, you know that this is going to be a reflection. It's going to reflect over, and you said, the y-axis. If you did, you got it right. Congratulations. Good job. Okay, now, the difference, if we look at g of x here, we have negative 3 to the x power plus 1. Remember that negative, when it's outside there on that whole power, the negative means it's going to reflect. This time, instead of over the y-axis, it's going to reflect over the x-axis. All right, and then we have that plus 1, and it's not with the x value up here, it's outside of that. So remember, that is going to be your vertical shift on the y-axis. So it's going to be a vertical shift, and it's plus 1, so we're going to have a vertical shift up 1. Okay. Now, look at C. We have 3, r of x equals 3 to the x minus 2 power minus 1. So there's no negative with the 3 or with the x, so there's no reflection there. Erase that dot I made, okay? So there's no reflection, but I do have an x minus 2 up there. So remember, if the addition or subtraction is with the actual exponent or with the x value, that is going to be a horizontal shift. And because it's minus 2, remember minus 2, it's actually the opposite of what we think. So we're going to shift 2 to the right. And then we have the minus 1 there on the outside of that. So then we're also going to go down 1 from the original 3 to the x power. All right, and then D. We have s of x equals 1/2 to the 1 minus x power. Now, really, they did 1 minus x. We can think of it this way. You can, if you want, rewrite it. Make it negative x plus 1. I think it's a little bit easier to read. Because you have that negative x, and the negative is with the variable, not with the 1/2. That means we are going to reflect over the y-axis. And then we have a plus 1 with the variable. So that means we're going to go, plus 1 is really the opposite with horizontal shifts. So we're going to go to the left 1. So hopefully you remember that from previous sections and you're able to just read the graph, see how it's shifted. And that's really what they're asking for. You can plug them into your calculator, but I want you to be able to read the graph and tell me, well, the original function, like 1/2 to the x power, what they did to it is they reflected it over the y-axis and they moved it left 1. Okay, and the last thing we're going to do here is we're going to solve some elementary exponential equations. We're not going to do anything too hard. But we're going to look at the steps to do that. First thing you always want to do is isolate the exponent or the exponential expression. So we have 16x minus 8 equals 0 here. We wanted to isolate the 16 to the x power. So they moved the 8 over by adding 8 to both sides. And you can simplify if necessary. We didn't have to here. And next what we need to do is we need to, and this is probably the hardest part, we need to write an equation that has So the bases are the same. So before we had 16x was equal to 8. But 16 and 8 aren't the same number. I need to write them as powers with the same base. I do know that 16 we could turn into 2 to the 4th power. And then we still have that x there. So it becomes 2 to the 4x power equals 8 is 2 to the 3rd power. So that's how they got the 2 to the 4x equals 2 to the 3rd power. And then really what you do once you have that same base is you ignore the base because you kind of equated them to the same base. So then we just take a look and we solve the equation. We do the 4x equals 3 and we solve for x. So they divided both sides by 4 and we got x equals 3/4. And we're going to take a look at a couple of these, because that one, once you created your equivalent base, wasn't too bad, but they're not always that simple. Okay, so here we're going to start off with our first equation, and that's a. We have 25 to the x power minus 125 equals 0. So what I want to do is first isolate this power. So I'm going to add 125 to both sides. So I'm going to make it 25 to the x power equals 125. Now, again, I need to have the same base for both. And I do know 25 is I know I can convert that to 5, and 125 is also, I can convert that to a base 5. So this would be the same as 5 squared to the x, or 5 to the 2x power. And then 125 is 5 to the 3rd power, so it equals 5 to the 3rd power. So again, ignore the bases once they're the same, and really the equation we're going to solve is going to be 2x equals 3, and we'll divide both sides by 2, so I get x equals 3/2, and that's the answer to my equation. So x is 3/2. All right, let's take a look at b. b is the exponent's already isolated, so we have 8 to the y minus 1 equals 1/2. Now, 8 I know I can easily, and I'm going to move it over here, convert that to 2 to the 3rd power, but then it's going to be times our y minus 1. And then I'm going to make that, I'm going to distribute my 3. So 2 to the 3, erase that, 2 to the 3y minus 3. Now, 1/2. Remember, when you get a fraction for an answer, what kind of exponent do you have? It's going to be a negative exponent. So I know that 2 to the negative 1st power is equal to 1/2, because it would be 1 over 2. So now I have the same base. So again, ignore your bases, and we're going to solve the equation 3y minus 3 equals negative 1. And I'm just going to add 3 to both sides. So I have 3y equals 2, divide by 3, so y is going to be 2/3, and that's it. We solved our equation. All right, so what we're going to do here, just it's a copy of the last slide, but we're going to do just like one more example, because sometimes they'll be a little bit more involved. So we are this time going to solve the equation 4 to the 2x minus 5 power is equal to 8 to the x divided by 2 power. Okay, so now what we need to do is convert them to the same base. I do know that 4 and 8, I can make it into a power of 2. So remember, 4 is the same as 2 to the 2nd power, which is then going to be times your 2x minus 5. And then 8 is 2 to the third power, which becomes 3 times x divided by 2. Again, I don't care about the bases anymore, so I'm going to ignore those. But I am going to distribute up here. So this is going to become 4x minus 10 is going to be equal to, when we multiply, put a 1 underneath, so it becomes 3x divided by 2. All right, so to get rid of our fraction first, I think that's what we want to do when we solve this. So I'm going to multiply everything by 2, because that'll cancel out the 2's there. So now I have 3x equals, and it's going to become 8x minus 20. And then let's just move the 8x over to combine our x's. So I get negative 20 equals negative 5x. Then I'll divide by negative 5. So I get x equals negative 20 divided by negative 5. It gives me a 4. So x equals 4. So sometimes they look really scary, but they're not that bad, I promise. And that is it for section 7.1.